Hi everyone, my name is Lydia and this is what I wish they had taught me about econometrics and introduction. For all of the Marvel or DC fans out there, you know how without the Batcave there's no Batman and without the arc reactor there's no Iron Man? Well, what we're going to talk about today, it's exactly the Batcave of Batman and the arc reactor of Iron Man. We call it the CEF, the backbone of econometrics. So what is the CEF and why should we care? Because most of the time students never really hear about it and don't know what it really means. So let's fix that today. Let's go back to our example of how education relates to earnings. This is a very simple graph, a scatter plot that shows observations on years of educations and earnings. Now, for each level of education, we can take the average income of people at that exact level. So, for instance, let's say that we are concentrating right now on this level of education. So let's just call it at one level of education. We see all of these observations that fall right under here. If we were to guess where the average throughout all of these points would be, let's say it's somewhere right in here. We can do exactly the same thing and pick this other level of education, and we see here out of all of these observations the average would probably be somewhere around here. Then we can take more let's say another level of education right here. Out of all of these data points, let's say the average looks to be somewhere right here. In the end, all we have to do is connect these dots. And what you have done is actually just drawing the conditional expectations function, or the CEF. So what you have done is to literally pick the average out of all of your earnings for this particular level of education, plotted it, doing the same thing repeatedly for all the levels of educations, and then just connecting those dots. What you have seen mathematically most of the time, though, is the following expression. So the expectation of y conditional on the x. And what that means is the expected value of y given x. In plain English, that would mean what do we expect y to be on average when we take a certain value of x. Now keep in mind, this is about averages across groups. It's not about individuals. The CEF is the simplest possible way to describe how two variables move together. Okay? So it does not really assume, and this is very important to remember, so it does not assume linearity. It does not assume normality or causality. It just summarizes how the world looks like on average. Because as we know, most of the times for anything we'll want to study, we'll never be able to get the data for the entire population. So most of the times we're going to work with samples and we're going to look on average, because we'll never be able to very exactly and perfectly predict things. So again, the CEF helps us summarize how the world looks on average. Now, why this is important? Because everything we do in regression, so all the betas that we mentioned in our previous videos for jargon in economics, or t-stats, or p-values, which we're going to learn in the future, are built around trying to approximate this curve. So what you usually do when you run regressions is trying to find the linear line that best describes this CEF curve, which we just said does not need to be linear. Okay, and as you can see in here, there is a little bit of a kink in this line that I was drawing by connecting the different dots. So again, regression is just your way of finding the best fitting straight line through the true CEF. So the next time you hear about the conditional expectation of y on x, think of it as like, this is what it's going to give you, the true pattern behind the data, so the average story that the regression is trying to tell you. Hope this was helpful, and I'll see you in the next video.